want to show you an application problem where we may use a substitution or elimination at the end to actually solve for the values. But starting with the word problem, let us actually go ahead and go through and try to understand the wording of the problem. I have already underlined the key information which we will be using in order to kind of set up the equations, and once we set up the equations, then we talk about the solution methods. Okay, so here it says Jenna is babysitting in the summer, and while she babysits, she charges $6.50 per infant, and she charges $9.50 for any children over the age of 3. Now, while she does that, she makes a total of $202.50, and the number of children that she babysits is 27 children, which I have already underlined the key information. Now, given this piece of information, we want to find how many infants and how many children over 3 did she babysit during this whole summer. Okay. So guys, in order to solve something like this, again, let me also mention the fact that there is so many different types of word problems out there. This is like maybe one, there's probably hundreds of them out there. So guys, you can use the techniques that I will show you for this particular word problem, but you should actually go ahead and try to practice many more word problems from your textbooks or from other resources that you are using for your learning. Okay. So here I'm only going to show you one example, and then in my next videos I want to talk about how to solve a system of 3 equations, okay, which is going to be a little more fun and exciting for us. So let us talk about this particular example. Guys, when it says how many infants and how many children over 3 did she babysit, that should give us a clue, that should be our starting point. So for something like this, the starting point is, let X be the number of infants, okay, and then similarly we are going to say let Y be the number of children over the age of 3. So Y be the number of children over age 3. Guys, that should be our starting step, because we know that we want to somehow convert this information which is provided to us in words in terms of equations, and once we have them in terms of equations, then we will be able to kind of go back and see if we have learned or if we have the tools and we have the prior knowledge to actually solve those equations and actually answer these problems. Okay, so if we start with this X, where we say let X stand for the number of infants that she babysits and Y stands for the number of children over 3 that she babysits, then going back to the given pieces of information, it says what is the total number of children that she is babysitting? Well, there's 27 children. So from the given piece of information and from what we are starting with, we can say that the total number of children, which is X plus Y, so total number of children as a mathematical formula would be X plus Y, and we already know that equals to 27. I'm going to treat that as my equation 1, and then let us say if we can also write an equation 2, because here we are thinking about it's a system of equations and there is additional pieces of information which are provided to us. Now it says $6.50 per infant and $9.50 per child. So, and then we also know the total earning. So if there are X infants, then for each infant, if she makes $6.50, then for X infants, she's obviously going to make $6.50 times X, right? Because for one infant, she's making $6.50, but we have X number of infants, so it's going to be $6.50 times X. Then plus, for one child over the age of 3, she's making $9.50, but we have Y children over the age of 3. So the total amount that she's going to make for Y children over the age of 3 is going to be 9.50 times Y. And we also now know that the total amount that she's going to make by babysitting for both these, for infants as well as the children over 3, is going to be 202.50. So the sum of these two is going to be 202.50. And this is like my equation 2. Okay, so we have the first equation, we have the second equation. So what happened here, guys? We underlined, which I had already done that. So we underlined the key pieces of information. Then we started by assuming let x be the number of this and y be the number of the other one. And then from that, we try to create a model. We try to create an equation. In this case, it is not just one equation, because given the pieces of information, we can actually create two equations. Similarly, there could be scenarios and there could be applications where one may be able to actually create three system of equations or more system of equations, okay? So in this case, we can only create two equations, and so far we have already learned how to solve a system of 2 by 2 equations. So guys, let us talk about the solution methods for this. You can use the method of substitution, or we can also use the method of elimination. Here, let us see what we can do. Guys, before we use any of the methods, I want to simplify things a little bit. So how are we going to be able to do that? Now, first, what I would like to do here is, I see these decimals here occurring in all these three terms, so I would like to get rid of the decimal, okay? I mean, guys, that's not the only way of doing it. If you want to keep the decimals, you can, and you can use substitution or elimination right away. But I mean, here, I'm going to get rid of them. That is going to make life a little easier for me. So to get rid of this decimal, I'm going to multiply both sides by 100, okay? So if I multiply this equation 2 by 100, then this is going to look like 650x plus 950y, and this is going to be 20250. Okay, so I multiply this equation by 100. Why did I multiply by 100? Because there's a point after two places. There's a point after two places. That's why I multiplied by 100, so that I can get rid of that decimal. Okay, so once I have this, I would still want to simplify this equation furthermore. Well, all of these have zeros at the end, so they are all divisible by 10. So I'm going to divide all of them by 10. So let us say we divide this by 10. Of course, we have to divide each and every term by 10. Guys, once we do that, what do we get? Well, the zeros, it's 650 divided by 10 is 65, or you can also think of the crossing of the zeros, but the right way is to think of 650 divided by 10 is 65. And then you divide 950 by 10, you get 95y, and here you divide this by 10, you are left with only 2025. Okay. Guys, this transforms to this. Now we can still simplify this by dividing both sides, all the terms by 10. Now if I look at this, I still feel like, guys, again, since, I mean, we have to try to simplify things as much as we can. So when I look at this expression or this equation right here, I still feel like these three terms are still divisible by, I would say, 5. So I'm going to still try to divide these by 5 and see if I can still simplify them further. Okay. Well, if you cannot simplify them any further, then you got to stop, and then you got to start using the method. But here I still feel like these are divisible by 5, so let's go ahead and divide them by 5 as well. Okay, so dividing by 5, dividing each term by 5, dividing each term by 5. So once we do that, this is going to become what? Let us take it up here. I'm going to get 65 over 5 is going to be 5 times 1 is 5, and then it's going to be 5 times 3, so it is 13x. Then I have to divide 95 by 5, so it's going to be 5 ones, and then 9. And on the right hand side, it would be 405. That is my equation 2 transformed. So look at my initial equation 2, and now by doing these simple mathematical operations, it is simplified to that. So I think I like this more than this one, but I mean, guys, it's your own preference. And then I still have my equation 1, which is already like in a very simplest form. So I'm going to just bring it together here. So this is x plus y equals to 27. That is my equation 1. Okay. Now for these two equations, our goal is to solve for x and y. And once we have x and y, the x, we already know what the x stands for. X stands for the number of infants, and y stands for the number of children over 3. So once we solve for x and y, we basically have actually solved this application problem, right? So in order to solve this, again, we have a few different ways of doing it. Here in this case, let me see what I have. Like, I think I did the substitution method. So I want to stick with what I did in my notes. So yes, I think I did the substitution method. So what I'm going to do is I'm going to use this equation 1, and I think probably that's what you guys would be thinking as well, and I'm going to solve for x. So x is going to be 27 minus y. And then you already know what to do with this. You substitute this back in the equation 2 and then try to simplify. Okay, so I'm going to take this back here. So it is 13. And then x will be replaced by 27 minus y. That is my x. And then I'm going to add 19y equals to 405. Okay, guys, this is my equation 2, but now I have substituted the value for x. Now we already know what to do with this 13. You got to distribute this 13 carefully, and 13 times 27, which I have already done here in my notes, so it is 351. 351 minus 13y plus 19y equals to 405. Guys, you already know how to simplify these things, so I'm quickly going to do it right here, bringing it all together here. So it is going to be, when I simplify like terms, so this and this adds up to 6y, and then I have to subtract 351 from both sides. So when I subtract 351 from 405, I think I should get 54. Yes, that's what I have here. So I get 54 when I subtract that 351 from both sides. Now to get y by itself, I got to divide both sides by 6. I do that, I get y equals to 9. Y equals to 9 means that the number of children over the age 3 is how many? 9. There's 9 children over the age of 3, because y stands for number of children over age 3. And then to find x, we already know how to find x. We can go back to equation 1 or equation 2, or we can go back to this equation because that one is already solved for x. Okay, so let us go ahead and substitute the value for y and solve for x. So x equals to 27 minus 9, which is 18. That means the number of infants is 18. So she is, to bring it all together, so she has to babysit 18 infants and 9 children in order for her to make with how much, $202.50 during the summer. And of course the total number of children that she's babysitting is 27, and which makes sense here. 18 plus 9 is 27. Okay, so guys, I would like you to kind of take some time and just go over the whole process here. Again, there's few things to kind of take in here. One is like how to set up the problem first, then you write the equations, and then sometimes you get equations like this where you have decimals, or you may get some little more complicated equations. Then again, like, just guys try to figure out or try to learn the method, like how you can simplify this or get rid of the decimal first, and then first I got rid of the decimal, then I see like, oh, all of them have zeros, so I can still divide them and simplify them. Guys, I think the idea is like to simplify as much as you can, whether you are solving equations or working on some other mathematical concepts. The idea is to try to simplify as much as one can. Okay. Then when I looked at this equation, even when I was actually working on this example myself, like I got this expression and I asked myself, like, should I directly substitute from here to here, or I should simplify this? So I thought like it is better for me to simplify. So I simplified from here to here. Then I realized once I got this equation right here that they're still divisible by 5. So I divided all the terms by 5 and I got this piece. And right here I had to stop because these terms, looking at the coefficients here and the right hand side, I could see that I cannot divide by a common number. So I just stopped right there. Then I brought in my first equation, used the substitution method, and finally we got the number of children over age 3, and we got the number of infants. Okay. So guys, this is going to be my only word problem right now. If you have any other questions about these word problems, feel free to let me know, and I'll be happy to actually work on those. But in my next video, I'm going to be talking about the system of 3x3 equations, and I'm already like excited for 3x3 equations. Okay, but we had to learn and talk about a system of 2x2 equations before we can actually start learning 3x3. Okay, thank you. Till then, take care.